Welcome to Scholar Opportunity Nexus, and in today's series of video, we'll be looking at bearing representation of vectors. In our previous video, we introduced what a bearing is. We spoke about bearing being what an angular representation of a direction. We spoke about some conditions or some things you have to know when dealing with bearing, such as bearing must have a 3 digits, like 3 digits 009 degrees. Bearing must be represented in this form. We also spoke about bearing starting from the north. So every bearing starts from the north and it goes clockwise. We also spoke about bearing being in 3 digits and being mentioned one by one. So something like this, we mention it 009 degrees, not 9 degrees. So today we'll be looking at how to represent vectors using the pairing. Let's take our first example. Let's see, one, draw, and let's see, represent vector A 0, 0. Let's take 052 degrees in bearing form. So our first example, they said represent vector A that has a magnitude of a direction of 052 degrees in a bearing form. So now we know that yes, we are coming to represent it in a bearing form, and how they've represented the direction or the angle of the vector is exactly in the bearing form. So first we have to draw our cardinal points. Yes, we have to draw our cardinal points. So north, east, south, west. So we are representing a vector with direction 052 degrees in bearing form. We know that when dealing with bearing, we always start from north going clockwise. Clockwise is this direction and anti-clockwise is this direction. So we know that, and we also know that between north and east, the angle is 90 degrees. Between east and south, the angle is 90 degrees. Between south and west, the angle is 90 degrees. And between west and north, the angle is also 90 degrees. So when looking at this angle, that's 052 degrees, we are starting from the north, right? So the angle will be between north and east. To be between north and east. So we draw imaginary angle. We are going clockwise. So 052 degrees. But since it's the angle form, we just write right here. This is 52 degrees here. So with the direction always matters when dealing with pairing or every representation of a vector. The direction really matters because that is what distinguishes a vector quantity from a scalar quantity. So this direction, this shows 52 degrees. We took it from the north and going clockwise. So since 052 degrees, that's in the bearing form, is between north and east. This is how we represent this vector quantity. Let's take another example. Let me just change here. Let's take 1, 6, degrees. So with 163 degrees, we will do the same thing. We know that from north to east, the angle is 90, and 163 degrees is greater than 90. And from east to south, the angle is 90. So when we start from the north clockwise going to the south, we see that the total angle will be 180. That's 180 degrees. So taking this, let's clean this. So we know that this is 90. So 90 plus what would give you 160. Doing that calculation, you get 73 degrees. So meaning we draw clockwise. See, this is 73 degrees. Direction of A. So here is 73 degrees. Here is already 90. You know that here is 90. So this whole bearing form, we won't write the whole 163 inside. No, that's not how we do it. Just know that already from here to here is 90 degrees. So we just add the angle that the supplementary angle to get our 163 degrees. So that's 73. So you just say vector A 163 degrees. We already know the vector has a magnitude, but right now we are just focusing on its direction using the bearing form. That's why I'm not bringing the magnitude inside. So yes, we start from north to east, go back like this. So clockwise, and when you add them, you see that you get 163. That's 163 degrees. But in bearing, we mention it 163. Please take note of this. It is very, very important. Let's do our last example. And you'd go and try the rest home, or the rest when you are at your free period. You try other examples of how to represent vectors in bearing form. So our last example would be, let's take 290 degrees. So 290 degrees, representing it using a vector, a bearing form. So when representing this, we already know that each angle between all the cardinal points respectively is 90 degrees. So we start from the north, we come here, 90 degrees. Is it up to 290? No. We come here again, another 90. When we sum it up, it's 180, 180. Still not up to 290 degrees. We come here again, another 90. We add it, 270 degrees. Still not up to 290 degrees. Then we know that we have to add an angle to this total angle to get the 290, and that will be 20 degrees. So here we'll have our 20 degrees here. This is just representing it here in the cardinal points. So we won't bring the 0 over here for the 20. So we'll add 20 degrees to this. So we have this. Sorry for my crooked lines showing the direction. So this is A bearing from 290 degrees. Yes, so we always know that one, we are starting from the north and going clockwise. You just have to be getting the angles. If it's not up to, you add an angle to it that would give you the exact bearing angle that was given in the question. That will be it for this video. Thank you very much for staying up to this point. And if you're still not subscribed to Scholar Opportunity Nexus, I urge you all to subscribe now. Thank you.